It's nighttime in ancient Greece, and Greek philosophers are thinking about the world around them. Some of them arrive at the hypothesis that everything there is was ultimately made out of small, dot-like objects that eventually make the world. Indivisible was the concept they arrived at, it being the last form of matter, and the Greek word they gave it was the word atom. Democritus, one of the philosophers, said, "In truth, they're only atoms and the void." And if physics has taught us anything, is that, besides how poetical this may seem, boy was Democritus wrong. This concept of point-like particles making up matter was not much reported or researched back then, so it would be left untouched for a very long time. Jump forward in time, thousands of years into the future. There is a substance called tin oxide, which is composed of tin and oxygen, but the particular thing about this is that it comes in two different forms, and one has exactly twice the amount of oxygen as the other. We can spin it and break it and cut it in half, and it will always be that same 1:2 ratio. So, in a pool of confusion and randomness, how is it that it is always that way, that exact same proportionality? Well, in 1803, an English scientist by the name of John Dalton said he had an answer to this dilemma. He proposed that the substance was made out of tiny particles of tin and oxygen that paired up with each other. In one form, they did it in pairs, and in the other, a tin particle paired up with two oxygen particles instead. And he said that all matter was composed this way, by these tiny little particles that paired up with each other in order to form multiple different things. The name he chose for these particles was the Greek word used millennia ago, atom. Now that you know a bit about the history of atoms, there is one thing that I have to note. Both the Greeks and John and many others jumped the gun a bit on their nomenclature for the atom. You can think of matter sort of like an onion. Just as you can peel an onion, going deeper and deeper into its layers, you can also peel matter, going deeper and deeper into its substructures. We, humans, are organisms. Organisms are composed of organs. Organs are made out of tissue. Tissue is made out of cells. Cells are made out of molecules, and molecules are in turn made out of atoms. And it is here where we get to the mistake. The Greeks thought that the chain ended here, that there were no more layers, that the atom was the center of the onion. But in truth, the so-called indivisible particle is not that indivisible at all. If we peel the onion one more time, we see it for what it truly is. Not a simple tiny sphere, but a more complex system of even smaller things. So, let's take a look at what these parts are. We can basically divide the atom into two parts, the nucleus and the electric cloud. The nucleus is made out of protons and neutrons, which stick together due to two laws called the strong nuclear force and the weak nuclear force. The electric cloud, on the other hand, is made out of tiny electrons which orbit the nucleus in set orbits, by the Bohr atomic model that is. So now, instead of a tiny dot, we have a more complex system made out of three different particles, each with its peculiarity. Atoms, by definition, need to be electrically neutral, but the same does not apply to its constituents. Protons are positively charged, while electrons are the opposite, each with the same strength but of the opposite sign, and neutrons, as their name suggests, are neutral. Protons and electrons seem to be the stars of the show, playing a crucial role in the atomic system. They both have to balance their quantity in order to cancel each other out, thus making the atom electrically neutral. If there were too little or too many of one kind, the atom would be no longer. When an atom loses or gains an electron, it loses its electric neutrality and is now called something else, an ion, being a whole new other thing that is part of another conversation. But let's get back to the onion again, shall we? Before, we peeled a tiny ball and saw that there was more to it. So, what happens if we peel the onion once again? Well, behind most of these atom-making particles are even smaller atom-making particles, otherwise known as quarks. To put it in other words, quarks are the particles that make protons, neutrons, and so much more. They are the next layer of matterception, if I may. Quarks are divided into 6 main types or flavors: up, down, top, bottom, charm, and strange. They, such as atoms, get together, this time to form hadrons, composite particles that in turn make atoms themselves. I don't want to go too much in depth about quarks in this video, so there is one last thing which I would like to point out. Before, the Greeks thought that the atoms were the last frontier. The same thing happened again with hadrons, and now we have quarks, and we have not yet been able to peel that layer of the onion, if there even is one. Quarks are the last layer of matter known to man so far, so the question remains, is there more to it, or have we reached the bottom? Will we, hundreds of years into the future, discover an even smaller particle that makes quarks, redefying physics once again? Well, that is a bit too much speculation for one day. So far, we know that quarks exist, and physicists across the globe continue studying them and making achievements in the field to this day, making theoretical and practical breakthroughs that have shaped the world as we know it. From MRIs to the wave function, quantum physics is a very interesting field that changes our lives in one way or another, and I hope that I have helped you understand it a little bit more today.